Okay, so I'm going to add a little bit of information here. Remember that a y-intercept is where the graph crosses the y-axis. So that would be 0, comma, y, which means if you have x and y here, you have the x coordinate, so you should plug it in. So f of 0, 0 plus 3, right, PEMDAS, so that's 8 minus 1. So the y-intercept is 7. Number 2 is a little bit trickier because it's asking for the x-intercept of the inverse. Well, I'm going to translate. What if you wanted to relate it to f of x? Because f of x is what you're given. Can you change this sentence so that you have f of x here instead, but you're looking for a similar point? What switches on inverses? X and y. Anything for x and y switches. So if you can translate this statement about an inverse to this statement about the original, you're going to be finding a point that you can use. All right, keep going. So this is right 1 down 2. There's my center. Okay. And it's a growing log. So I've got my 1, 0 point, and it looks like this. Now I didn't put any other points on it, but that's basically what the log graph looks like. If I wanted to then do the inverse graph in green, I'll do inverse in green. That would just be switch the points. So let's see if I can label this point. This one was 2, negative 2. This is x equals 1. So in order to find an inverse, everything gets switched. The asymptote turns to y equals 1. The point switches negative 2, positive 2. Now this is a base of 3. That means that the inverse is also base 3, which makes it a growing exponential. Now, these 2 points, these are the 2 points that that sentence references, right? On the log graph, and then on the x. Oh. Does the green graph have an x-intercept? No, it doesn't. Doesn't exist. Does a y-intercept exist on the original? No. So if you're looking at the point, okay, so y-intercept of f of x would be 0, comma, y. Plug in 0 and see what happens. Y equals log base 3 of negative 1. Oh. It's undefined. That statement can't be evaluated. Because you can't do a log of a negative number. True. So in this particular one, it doesn't exist. Now if I had switched those words, right? X and y intercept, then it would have worked. But notice how those points, you'd be getting the same numbers. You would just go back and switch it to find it. So when I'm looking at points on a graph, maybe graph it to help you figure out what you can do with it. Okay. Can anyone tell me what the first one simplifies to? You raise your hand. Who's got the first one? Yeah? X. Okay, how'd you get it? Okay, so, right, equals y. Maybe I can evaluate this. 2 to the y equals 2 to the x. Oh, so it simplifies to x. Okay. Remember the properties that we did last class? What can that exponent do? Exponents, right? Using my property, I can bring the exponent down in front. What's log base 2 of 2? In unison. Log base 2 of 2 is equal to 1? 1? Yes? Okay, maybe do some jumping jacks. Log base 2 of 2 equals 1? Yes? I don't think everyone agrees yet. Yeah? Okay. X. There are two ways, right? This is one of the first ways we learned with rewriting it into an exponential and then simplifying and solving. What we learned last class was using your properties to rewrite. Well, rewriting can help you evaluate. Okay, so do 2 and then 3. 2 is similar. 3 has an extra step. Letter that's not there, right? So if 3 has an X, don't use X. Okay. I'll do it 2 ways. Let's put a Y. So you're like, all right. Circle my base. 3 to the y equals 3 to the 4. So y equals 4. So 4. Okay. Exponent comes in front. Right? Exponent can come in front. And log base 3 of 3 is 1. 3 is kind of tricky. The bases don't match. I can still do this with the equal to y. 4 to the y equals 16 to the x. A little bit of rewriting. So y equals 2x. It's okay to have an answer with a variable in it. It is. All right. Now, the exponent, I'm going to write this as x times log base 4 of 16. Well, log base 4 of 16 is 2. So you get 2x. Notice that we have a property on that second row. In here, it was just converting forms. So we've got an inverse property. This is the simpler of the inverse property, and we're going to write it down. Okay. Okay. Log base b of b to the x equals x. I'm composing a log and an exponential. You always get the exponent. Look at that, right? The exponent comes in front. Log base b of b is x. Right? Maybe I do a little bit of work over here. It's called an inverse property. Now I'm going to go like this. They just cancel each other out. But I actually want you to understand why they cancel each other out. It's equal to x. It's not equal to 1 to the x. It's just x. Because that exponent comes in front. It's an inverse property because you're mixing the log and the exponential. Now there's a fun inverse property. This is the one that's easy. It makes sense. Okay? So I'm going to turn my page because I'm out of space. You can do it right here. This is going to start our notes right here. Okay? Okay. In your table groups, it doesn't matter. See if you can figure out, right? We're going to start notes on inverse property, which is going to take us into some of our solving today. Okay. I'm going to put up a couple statements. Figure out what they simplify to. Okay? Talk to each other. Come up with a reason. Three of one.
That's a good song.
Yes. Okay. So, I wish I had lined paper here. I mean, I have lined paper, but this whole thing is the exponent. So the exponent has a subscript. Yeah. Right? This log statement is the exponent. The whole box is the exponent. Okay, we're going to get a little bit creative here.
That sounds like the name of a terrible rap song.
Okay. Let's go with that and see what you come up with. There's only two that are a little bit tricky, right? 3 and 4 are a little tricky. See if you can figure out what it evaluates.
Let's do this now. I mean, if someone walked in and like,
What's log base 3 of 9?
all of your salsa,
What's the base squared? Right, just work your way. See what you can evaluate.
I mean, well, no, but active chugging salsa, no matter how spicy it is, an insane act.
Okay, what's log base 3 of 9?
That's x equals 3. X equals 2.
Wait,
X equals 2.
Sort of close. Okay. That's what I'm going to call it. Magic. Can you tell me? Okay, log base 3 of 8 represents equals, let's call it m. 3 to the m equals 8. It's the exponent that gets you 3m equals 8. It's what if that exponent gets you from 3 to 8. So give me a decimal. What decimal do you think it is? It's like just under 2 because 3 squared is 9. Okay, you see where 3 to the m power equals 8. Okay? Yeah, it's like you gotta say the sentence like 3 till you're like, So if this is m, 3 to the m is what? Yeah. Magic. Okay. First two. Who wants to tell me the steps, right? There's 2 steps here. Can somebody give me the first step on how you simplified this? Sure. Log base 3 of 9 is 2. So 3, yeah, okay. And then 9. All right, you're like, yeah, I can evaluate that. Okay, second statement. Somebody else. What do you do first? Yeah, Ronan. Correct. Yes. I'm going to highlight something for you to look at. I'm going for understanding the property, not just writing the property down. Okay. Number 3 takes a little bit of magic, so we're going to do 4 first. Just a little bit. Okay. Anyone have an idea? I noticed that 9 and 3 don't quite match, but can you write the 9 with a base 3 instead? Okay. 9 as a base 3, so now I've got the exponent. But that coefficient of a log can actually be the exponent, right? Move it. The reason I want to move it, okay? Yeah, the sizing of things is very tricky. Oh, I don't know. Can I even do that? No? That's okay. We're going to leave it there, and we're going to go back and we're going to do this one. Because you can't, right? I got here, but I don't know what to do from there. I'm going to explain it to you. Okay. I'm going to say this. I'm going to change my exponent to the letter M. And then I'm going to do a little work. Okay. So log base 3 of 8 is M. I'm just substituting it because I can't figure out what log base 3 of 8 is. I don't know what it is. It's a number between what 2 integers is this between? Don't yell it, raise your hand. What 2 integers is log base 3 of 8 between?
2 and 3.
Too high. 1 and 2. 3 to the first is 1. 3 squared is 9. This number is between 1 and 9. I'm going to call it M for magic. Okay? Because it's going to feel like magic. The number, or I'm going to call it the exponent, that's between 1 and 2. Kind of close to 2. Right? Like 1.8. 1.9. I don't know what it is, but I know it's kind of close to 2. Okay. The number, or exponent, that gets 3 to 8. Right? 3 to this power gets you to 8. Right? Feels like magic. When the sentence makes sense, it's going to feel like magic.
But is it what I think it is?
Yes.
She's using magic today.
It comes down to 8. Comes down to 8. That's what this simplifies to. Okay. M, look at what M is. M is this statement right here, which is the exponent. Look at where it is. This number is the magic number that gets you from 3 to 8 in the exponent, right? 3 to the M power gets you to 8.
The big mosquito gets featured.
Yeah, M is some decimal number. I don't know what it is, but I don't need to know what it is. Okay, here's where the magic, it goes like this, guys. They cancel each other out because they're inverses. Look at the base 3. Look at the base 3. I don't want you to just slash things off and not understand how it could possibly work. It does work, for real. It's just a kind of a complicated sentence to get through. So you're like, you get to number 4, and you're like, the bases don't match. I can't cross them off. But if you can do a little bit of property rewriting, they match, and you get x squared. Okay, it's an inverse property. They undo each other. The base 3 and the base 3 of the log, they cancel out. And you are left with the argument. Yeah, the answer is just 8. Okay, look at, right, the first 2 examples were the matching, and you could evaluate. 3 to the log base 3 of 9 is 9, because you worked through it, and you did it.
So will the magic number problems always be given in these sets of multiple problems?
They'll be, so let me write a new problem for you.
Because like 9 minus 1 equals 8, does that have any like connection?
No, it has no connection. So,
Just write the magic number that's...
yeah, you don't even have to write this. I'm just explaining it to you. Okay, so let's try this. 4 log base 4 of x. I don't even need a number here. Because the base 4 and the base 4 match, it's kind of like magic. They cancel out, and you are left with x. Okay, so m. I'm going to think of it like this, where m equals this statement. Because I don't know what this exponent is. Okay, I don't know what it is, but let's rewrite it. 4 to the m equals x. M is the exponent that gets you from base 4 to x. M is the exponent needed to get you from 4 to x. What is 4 to the m equal to? X. Do you have to show me the steps? No. You can just write x. But I do want you to understand there is a specific process. I'm not making it up. It does work. You can prove it. Okay, so I'll do one more. 8 log base 8 of 2x. Do you have to show that rewriting part? No. The rewriting part is what's telling you how to how it works. So 8 to the m, where m equals this, means 8 to the m equals 2x. Do you see what is 8 to the m equal to? 2x. Okay, I want you to open up your homework packet to worksheet 8. That's where these practice problems are. Okay, let's take we'll start with 4 minutes, maybe answer a few questions, give you another 2.5 to 3 minutes to try some of the problems before we move on to a little bit of solving. Okay, here we go. Eyes up. Eyes up, eyes up. Number 17. You're like, 5 exponent. I'm going to highlight the whole exponent. That's the whole exponent. It's got a plus 2 in it. Yes.
Is the plus 2 like separate from the 17?
It is separate from the 17. If they were together, I would have put them in grouping symbols, or I would have put 19. Okay, so you're right that the 5 and the log base 5 are going to cancel, but like that 2 over there. Okay, look at what I did. I used my exponent property to separate the log exponent from the number exponent. Okay, so yeah, this one cancels out and I get 17. But the 5 squared is 25. I'm not going to multiply those numbers together. 17 times 25. I'm not going to ask you to multiply numbers that end up being bigger than 100. I don't need you to do that.
Couldn't you also use 19?
No, it's not. There's not grouping symbols. All right, 18. Separate. Okay, times x to the first. See if that idea of separating your log exponent and the number exponent, see if you can make that work for the next 2 examples there. Careful with that negative. No, that's like one step. Keep going. So the negative 1
Would it be negative
goes to 72, right? Yeah.
Would it be negative 2?
No. And 72 to the negative 1 power.
What's going on over there? Why do I need to restrain you?
Your news.
Careful with the negative. When you have extra things separated, you gotta move it before the proper
You realize that yes, and there was a lot of places.
My English teacher started graphing yesterday in class.
It was a first and third. She's the best. I love her so much.
She's a street cat. That just
Doesn't matter.
Oh no!
Is it one? Is it just 172? Yes.
Separate this, separate the log exponent from the number.
Oh yeah. It sounds so fun. Last night,
You just left off this one.
yeah, and they went to Langley.
Nope,
That's the
times, right? Times. Okay, so my negative moves to the top. 72 to the negative 1. This cancels out. And 72 to the negative 1 power is 1 over 72 times x. That's it. We're mixing properties, right? You've got some log properties, you've got some exponent properties, you've got some inverse properties. 939. Well, I'm going to separate the exponents because they have different bases. And the second one, you're like, yeah, that one's pretty quick, I got it. X. But 9, log base 3 of x. I can't change the 3, right? The base of the log, you can't change it. Because you have to change the other one. And so that is a 3 to the 1/2. Because of the square root. And so my 1/2 moves, and I get x to the 1/2 times x, which is x to the 3/2. Yeah? There's a lot of steps in there.
What? Why is it 1/2?
Because what? Oh. I'm so silly. Whoa. That's because I was thinking of a different problem. Because I changed the wrong one. Okay, hold on. I got it. X cubed? Yeah, x cubed. Woo! It happens to the best of us. Oh, here you go. 3 squared. X squared. There you go. X cubed. Woo! I was thinking of the one down here. All right, let's do the last row. Okay, so 9. This is a little bit easier. My exponent comes in front. Log base 3 of 9 is 2. 2x plus 2. You can do it the inverse property way. You can also just do the move the exponent to the front way.
When you see she's writing up some divorce papers.
Here, x log base 4 of 2 is 1/2. I'm not doing it the inverse property way. I'm just moving my exponent down and I'm evaluating. I'll do the last one the inverse property way. Log base 4 of 4, 2x minus 2. And I'm like, oh, they cancel out. But be really careful. That comes down as a 2x minus 2. Solving. Yeah. I know. Right? There's 4 types, so we're just going to write the types up here. Yeah, I left a blank on purpose. Yeah. Yeah, sure. We've already done 2 types of solving. We've done the first type, matching bases and exponent properties. We've done the third type. Look at where the x is, because we're always solving for x right now. Okay, how do I solve this for x? I could rewrite it. Okay, implies that b to the y equals x, and then you have x by itself. It's rewriting. So we're going to add 2 types of problems today, ones that look just a little bit different. It's almost like, why haven't we done row 2 yet? Anyone think they know what goes here? Don't yell it, just raise your hand. Do you have an idea of what would go here? Give them just 30 more seconds, then I'll ask you. Just likes to. Okay, I saw 3 people think they have it. 4.
Wait, you said think.
Well, anyone else think they know what goes here? Sam? What goes there? Yeah. It's the same thing as matching bases from the first line. Corresponding parts are equal. Be very careful though. 1 exponential equals 1 exponential. 1 log equals 1 log. There's no extra parts here. Okay, and then notice that we're solving for x. That's what we're trying to get by itself. So it matters where the x is in the equation. So I'm going to give you one more here. B to the x equals y. How would I solve for x in this particular case? Right? You've kind of learned all the skills you need. Now we just have to try to pick the right one when we're solving for x.
Log base y equals x.
Yeah. Just rewrite it as a log. Do a lot of rewriting to switch the location of exponents and arguments so that you can solve for the quantity that you want. So I'm just going to put up examples, and we're going to try to categorize which one we're in so we can think of which skills to use. Okay, so let's solve for x. Four times e to the x plus 2 equals 10. Which category do you think you're in? 1, 2, 3, or 4? Yeah, right, it's an exponential, so 4. We're going to need to rewrite it into the log form. But before you do that, look at that. You got to isolate the exponential before you rearrange it. So let's divide by 4. 10 over 4 is 5/2. Okay. And I'm actually going to introduce to you something to help with the rewriting. It's called logging both sides of the equation. It's kind of like dividing, except you can't divide e because it's a base. It's not multiplication. So we actually need an inverse operation. And so the inverse operation, so far, we've called it rewriting. It's also called taking the log. Logging sounds logging both sides of the equation. And this is what it looks like. You literally just write log base e on both sides of the equation. Just how you would divide both sides of the equation by 4, you log both sides of the equation. Give it 1 second till we get to the next line.
Couldn't we just do log base e? 5 equals x plus 2?
Wait till this line right here, and that's what we're going to get. But sometimes you want to see the operation, because when it doesn't match, it's nice to be able to write it down. 1 second, let's finish it. So I'm going to rewrite. Okay, whatever was in, right, whatever's on the left side, that's what I'm going to write. Whatever's on the right side. Oh my gosh, that inverse property. Yes. That's how it works. Right? I just showed you how to rewrite it. It was a skill, but this is like the proof of why that works. X plus 2 log base e of 5 over 2. Could you write natural log ln? Yes. Yeah, that's fine. I just like to see all parts of the log. Do I have x equals yet? Not quite. Just minus 2. There you go. X equals. You do not need to evaluate that. Just leave it. Just leave it. Okay. Okay, solve for x. Look at where your x is and what strategies you would need to solve. You gotta get just have it written because it was in the other pile.
Oh no. So you divide by 3 for this, like, wait, what's that one again? Natural logarithm. So the reference process is equal to
So would you multiply both sides by e to the x and then cancel out and you get
Remember, kids, if a goop is running at you, all you have to do is kick it. Birds have hollow bones. They break easily.
Okay, this is category number 3 because the x is inside the log. Now, you have a couple choices. You could move the 3 to the power, or you could divide. I would prefer to avoid exponents if possible, right? Dividing is easier than making that a power. So I'm going to divide by 3, and I'm going to write this as log base e, and the inverse operation is called exponentiation. Which really just looks like rewriting it. That's what it looks like, okay? It's called exponentiation, and it looks like this. E. Okay, I created the base e, and whatever is existing, the left side of the equation becomes the exponent. And then you're like, oh, it's the inverse property that allows me to rewrite this. Which is just rewriting it. That's all it is. The inverse operation is rewriting it. And then I have x equals. That's it. X equals is what you're trying to get. So we've done example 3 and 4, right? The types, right? Starting with an exponential, starting with a log. So now we're going to pick something from the first 2 categories. Log base 2 Okay, so you've got multiple logs. There are 2 choices here. Try to make one and see if you can find x. This can fit into 2 categories.
Is there a difference between
When add a negative or subtract a positive. This can fit into 2 categories. Think about which 2 categories you can make it fit into.
This is indeed thing from Wait, so we can.
This is the only one that's
Two Microsoft tech support officials attempting to figure out how to fix it.
Yes, good. Yes. Yeah, because it implies.
I could have both for
Two Microsoft techs
I know that's what I'm doing.
Then yes, that's fine.
argue over how best to fix a computer. 2019 colorized.
That's the implication. I'm going to show you why. All right, here we go. I've got. Here's your quiz. Hold on. Thank you. Okay, I have 4 categories. Category number 2 has this. Log base B of A equals log base B of capital B. Okay, it implies this. Well, can I move this log to the other side in order to have corresponding parts of logs? Yes. Notice they're both positive. It's important not to have anything extra. Now, the property, it's called exponentiation. And so I'm going to write the base down, and I'm going to leave a spot to write in the exponent. Okay, it's called exponentiation. Can you just cross them off and be like corresponding parts? Okay, yes you can. X plus 1, log base 2, 4x minus 3. The inverse property is what allows us to do all of this rewriting. Okay, the inverse property is the proof behind it. X plus 1, 4x minus 3. Be very careful that it's 1 log equal to 1 log. And then you get x equals 4/3. But that was category number 2. What if I want to make this category number 3? Can you make it category number 3 instead? Category 3 only has 1 log. Can you do this? Can you turn the left side into a single log instead? The answer is yes. See if you can do it. See if you can do it. Well, how do you subtract logs? What do you do?
Because they're the same.
Same base. Properties work.
It's the same thing as
Eat a bag of sausage.
Can you turn the 2 logs into 1 log? Think of your properties. How do you combine them? How do you combine logs? Subtraction turns into division of the arguments. X plus 1, 4x minus 3. Okay, properties. How do you rewrite these statements to fit the format that you can use? Properties help you rewrite it. And then 2 to the 0 equals this. One way is not necessarily easier than the other, but you do need to recognize possibilities of rewriting it to make it work for you. Let's do a little cross multiply. Oh, and then I end up right exactly where I was before. I'll put a little note here. Use properties.
Chunk is looking pretty thick.
Okay, there's your next question when you're ready. I added a number in there. So just see what you can do.
That's what I told my parents. They didn't believe it. They're like, you can't trust all missions.
The question I had asked.
I just asked for like, it's a fun thing to do. That was really good.
She said that?
No, it's the end of you.
Okay.
Pick one of the formats that you make it look like to help move Yeah, okay, so you might need to combine the logs, or you might need to turn a plus into a log, so that you can either get one log equals one log, or you combine all of them in a number on the other side. Right? So think about your formats and how you can make it look like that to move forward.
This is a
Yeah.
This is a, you really should change.
Yeah, that works. Yeah, there's a lot of ways to move forward. You got basically, I'm gonna have to pick first two log formats. Log on both sides, log on one side, number on the other. I can also take my a plus one and make it log base form. Right, there's a lot of choices.
when you add two logs,
Yep.
so I turned to do one and
Yeah, so you're going to multiply 4x plus 8. Yes, that will work. Yeah, you just got to pick one of the log formats and use your properties to get there. Then move forward. Yep. I'm just checking my answer. Negative 11 over 3. I got 14 over 3. Oh, no, never mind. You're okay. All right, guys, here we go. You have two choices. You have choice number 2, choice number 3. Choice number 2 has one log on each side. Choice number 3 has all of the logs combined on one side and the number on the other side. But you got to pick number 2 or number 3. Okay, one of those formats. I will do both of them. The first thing I notice is that I could probably put the logs on one side and combine them, and then put the number on the other. So, log base 4, x plus 2. Let's minus this log over. And then put the number. All right, so I'm aiming for for setup number 3, which is a log equal to a number. And I'm going to use my property, which allows me to divide the arguments. My property of logs with subtraction allows me to divide the arguments. And then I'm going to exponentiate, which really means rewrite it. 4 to the negative 1 equals okay, now it turns into a rational, which is from the last unit. I'm going to cross multiply. Whew. Okay, negative 11 over 3. And hold on. I'm going to do the other format. I'll give you a second to catch up. Can I get a mixed number? Negative 3 2/3. I was just curious what two integers it fell between. Because the first thing I did when I looked at my answer is I looked back at my equation. I was like, does this make sense to me? Log base 4 of this. Doesn't make sense. I can't get a negative number inside of a log. I can't get a negative number here. It doesn't evaluate. So our algebra is not wrong, but it happened to give us an extraneous solution. Extraneous solution. So I need to cross it off, which leaves me with no solution. Why? Because it did not check. It didn't check. You cannot have a negative number. You cannot have a negative argument here. It does not evaluate. Right, think of your graphs. You've got asymptotes. You've got some undefined values. You have to check for that.
Do you have a negative inside if the base is odd?
No, because it doesn't match. Think 3 to what power will give you a negative number? Nothing. Okay, I do want you to see the other possibility. What if I'm aiming for 1 log on both sides? Sometimes the numbers are the trickiest. What if I just turn my number into a log? 1 is log base 4 of 4. Right? All logs instead. Equals log base 4 of x minus 3. Now I'm going to combine the left side to 1 log. That way is kind of nicer. I didn't have to divide. I don't really like the divide because it ends up with the rational. But the number was throwing me off because I was trying to work with it and I didn't know how to combine it. We'll turn it into a log so you can put it together. And then I exponentiate. Cross, cross. Can you just write 4x plus 8? Yes. Oh, that way actually seemed simpler to me algebraically.